Hello, class. In this video, we will start section 3.2. We're going to continue our work with linear functions, except this time we're going to deal with applications. Up until this point, we've discussed the slope and the y-intercept, but we've never really discussed their meaning or practical meaning. So we're going to see some real-life applications in this lesson, and we're going to discuss the practical meaning of slope and y-intercept. So let's take a look at this first example, example 1. Okay, so I'm just going to change my ink. It says identify the slope and vertical axis intercept in each of the following situations. Interpret the meaning, include units with slope. All right, so you have an air conditioner. They charge $75 to come to your home and an additional $50 per hour. And then we're given the linear equation that represents this scenario. And it says X represents number of hours and Y represents the total cost. Okay, so we have to talk about the slope and the vertical intercept. So the slope in this case is the 50, right? Because you remember in Y equals mx plus b, right? The m is your slope and the b is your y-intercept. I'm going to abbreviate and just write y-int. So looking at the problem, m equals 50, right? That's coming from here. And b equals 75. So I want to interpret what do these things mean to us. So to me, the slope is the rate of pay, the $50. So let me use my typewriter box here. I'm going to write the slope is 50, which represents the charge, right? We pay $50 an hour for the repairman. So represents the cost per hour. The vertical intercept is the 75, right? Or we can call it the vertical axis intercept or the y-intercept. They both mean the same thing, is the 75. And that's really the initial charge, right? When the contractor walks in your door, right away you owe $75. Then after that, you pay another $50 per hour. So I wrote the vertical intercept is $75, which represents the initial charge, right? As soon as the contractor walks in your door, you pay 75 bucks. Then you pay $50 per hour. And just remember, slope is really like your rate, right? The rate of pay in this case is $50 per hour. All right, let's try letter B. In letter B, we see that Clay received a $100 gift card. Every few weeks, looks like he goes to buy a magazine that costs $8.50. The linear equation represents this situation as f of x equals 100 minus 8.5x. So you think about it, if he starts with $100, every time he buys a magazine, $8.50 is deducted from that $100, right? So it's like if you had a Starbucks gift card and you had 50 bucks on it. If coffee's $5, well, every time you buy a cup of coffee, the $50 will be reduced by 5. So in this case, he starts with the $100 and $8.50 comes off of the card every time he buys X number of magazines. So let's write this up. I'm going to say that my slope is the $8.50, but it's negative, right? Because that represents a decline. And the y-intercept, which is also the same thing as your vertical axis intercept, right? That's your b, in this case is 100. Now I know you're used to y equals mx plus b, but you can also write y equals b plus mx. So in this case, the m is the negative 850, and the b is the 100, right? The b is the 100, and the m is the negative 850. Okay, and let's come up with a practical meaning. And I tried to type this down here, right? The slope is minus 850 because the value of the card decreases by 850 for each magazine purchase, or you could say the rate of decrease is 850 for each purchase. And the y-intercept, which is the same thing as saying vertical axis intercept. You see up here? So you could say vertical intercept or y-intercept, and that is $100, and that represents the initial value of the gift card. In fact, every time we talk about the y-intercept or the vertical intercept, usually it's the initial value, it's the starting value, okay? And then whatever we're talking about in the context of the problem. All right, let's keep moving. On the next page, let's do a practice problem number 2. I chose that problem because my dad was born in Bermuda, and I have cousins and family that still live in Bermuda. So I'm a little biased toward the problem that has Bermuda in it. All right. A student is planning to take a statistics course in Bermuda this summer as part of Brookdale's exchange program. It looks like she has a $25 calling card, and every time she uses the card, it looks like it costs $3.25 per minute. And so here's the equation that represents that scenario. Identify the slope and the y-intercept. And remember, y-intercept and the word vertical intercept are interchangeable, right? So I can say y-intercept or I can say vertical intercept. All right, so let's think about this. The slope, right, which is my m, and y equals mx plus b, would be negative 325. And the y-intercept, or the vertical intercept, same thing, which is my b, would be the $25. And I'll type up the practical meaning in the text box. So I took my mean, I wrote my meaning over here, right? So the slope, the rate of decrease in the value of the card will be 325 per card, per call. And notice I used the word decrease because of the negative sign. If this was a positive sign, there'd be an increase. Okay, so the negative sign just tells you the direction of the rate change, right? Either the rate of change is going up or down. For example, if you had a job where you get paid $3.25 an hour, this would be a positive, right? Because your earnings would go up by $3.25 for every hour you work. Okay, the y-intercept is the initial value of the card, right? Anytime I ask for the y-intercept or the vertical intercept, you can always start the sentence by saying the initial value of the, and then look at the problem and then fill in the blanks, basically. Okay, I think I'm going to stop here. Thank you for watching.